Section 4.4.5 homework assignment. We're going to consider the data set given in the table. We're going to complete parts A through D. So here is the table that's given. We want to construct a frequency marginal distribution. So here's our table. We're going to go ahead and then use that table here. The first thing we need to do is we need to determine what is the table total. So we need to add up all these values that are in the table and find a total. So if we take each value in our table, in this case we're taking 20 plus 25 plus 50 plus 30 plus 25 plus 50, that gives us a total of 200. So what we're doing is we're creating a frequency marginal distribution. So in the first column we have x1 and we're going to add 20 plus 30. So when we add 20 plus 30, that's going to give us a value of 50. Okay, the next column we're going to take 25 plus 25 and that gives us a total of 50. The last column we're going to take 50 plus 50 and that's going to give us 100. Now we're going to add up the total in the rows. So we're going to add together 20 plus 25 plus 50, which gives us 95. And we also see that 30 plus 25 plus 50 is going to give us 105. Okay, and then this is going to tell us that when we add 105 with 95, we should get 200. When we add 50 plus 50 plus 100 gives us 200 as well. So let's go ahead and fill in our information. So we have 50, 50, 100, 95, 105, and then 200. Okay, now the next question wants us to construct a relative frequency marginal distribution with this data. Okay, so what we're going to do is now we're going to create a relative frequency marginal distribution. So what we're going to have to do is we're going to have to take our values that we found here, so this 20 and this 30. What we're going to do is we're going to add those 20 and that 30 together. Okay, and so we're going to add 20 plus 30, and then we're going to divide it by the table total. So the table total is 200. We know that 20 plus 30 is 50, so therefore it gives us 0.2500. Okay, next we're going to take 25 plus 25 to get 50. We're dividing it by the table total of 200 to get 0.2500. Okay, next we're going to take our 50 plus 50, which is 100, and we're dividing it by the table total of 200 to give us 0.500. Now for the rows, we're going to do the same thing. We're going to add together the 25 plus 20 plus 25 plus 50, which gives us 95, dividing it by the table total, which gives us 0.4750. And likewise, we're going to take 30 plus 25 plus 50, that gives us 105, and then dividing it by the table total of 200, which gives us 0.525. And so therefore, when we add this column together, we should get 1. When we add these columns together, it's also going to give us 1. And let's just round it to 3 decimal places so that we can put in our correct answer. So this is 0.475. This is 0.525. This is 0.250. 0.250 and 0.500. So we're going to go ahead and then fill in that information. So we have 0.475, 0.525, 0.250, 0.250, and 0.500. Okay, now what we're going to do is we're going to construct a conditional distribution by x. So now what we're going to do is we're going to construct a conditional distribution. So what do we do here? Well, what we need to do is we need to take our value of x in this column, which is 20, and then we're going to divide it by the total in this column, which was 50. So going back to this result here, and I'm going to copy this information here so we can see what that result looks like. So from our marginal distribution, we know that the total of that value, the column for x, was 50. So we're taking the value of 20 and then dividing it by the total here of 50 to get 0.4000. Okay. Next, we're going to take the next value, which is 30, and then divide it by the column total of 50 to get 0.6000. Okay, now we're looking at x2. So we're going to take the next value of 25, and then we're going to divide it by the column total of 50 to get 0.500. And likewise, we're going to take 25 and then divide it by the table total of 50 to give us 0.500. And then the last one, we have 50. So we're taking the value of 50 and then dividing it by the column total of 100 to get 0.500. And then similarly, we have 50 again. We're dividing it by the column total of 100 to give us 0.500. And therefore, when we add each one of these, we should get 1 here, and then 1 here. Now let's go ahead and put our information into our solution here. 0.400, 0.600, 0.500, 0.500, and likewise for the last 3. Okay, now what we're going to do is we're going to draw a bar graph of the conditional distribution found in part C. We're going to let the blue left bars represent the conditional distribution of y1, and let the red right bars represent the conditional distribution of y2, and then we're going to choose the correct graph below. So I'm going to go ahead and open this data up in StatCrunch. So we have to manipulate this just a little bit. So using StatCrunch, okay, we're going to do the following. All right, so we know that VAR5 is going to have a column, and that column is going to represent x1 here. So I'm copy and pasting x1. I'm going to copy and paste x2, and then I'm copy and pasting x3. Okay, and then our column is going to be now y1 up here, and we're going to make this y2. Okay, and now we're going to put in what we got here. So that x1, y1 is 0.400. Okay, and then the next one over is 0.500, so that means this is 0.5, and then this is 0.5. Okay, then the next one, y2, has an x1 of 0.6, and then 0.5, and then 0.5. And now we're going to use this column here and those two columns there to create our bar graph. So let's go ahead and go to graph. We're going to go to chart and select columns. We want to make sure that y1 and y2 represent our columns. We want to make sure our rows are labeled in VAR5 because that is the column that we created for x1, x2, and x3. We want to make sure it's a worksheet. We want to make sure that they are vertical bars that are split. And we know that our y-axis is going to be a relative frequency, and we're going to use horizontal lines to determine if we have the correct bar graph. So here's our bar graph, and if we look here, this blue goes all the way up to 0.7, so it's not going to match that one. And the red goes up to 0.6, and this one goes up to 0.4, so it doesn't match that one. If we take a look at B, okay, the blue goes all the way up to 0.7 again, and the red goes to 0.6, so it doesn't match that one. And if we look at the last one, it goes to 0.4, this one goes to 0.4, this one goes to 0.6, that's 0.6, 0.5 and 0.5, 0.5 and 0.5, so therefore it represents the graph for C.